the public with their health is vital, and seafood is a solution.
Linda's welcome music. Cue music. Ladies and gentlemen, please welcome Linda Cornish, founder and president of Seafood Nutrition Partnership.
Good morning, everyone, and thank you so much for being here for the 7th Annual State of the Science Symposium. Welcome to all those in person as well as those that are joining us live via YouTube. And I'm Linda Cornish. I'm president and founder for Seafood Nutrition Partnership. I will be your MC for today. And so get ready, hold on tight for a wonderful program today. S&P's charitable mission is to inspire a healthier America through partnership and outreach through seafood nutrition. And this science symposium is produced by our Scientific Nutrition Advisory Council, chaired by Dr. Tom Brenna, and our Science Council is here with us today. By the end of this conference and symposium, we hope that you'll take away from these TED Talk style presentations on why seafood is essential for a healthier people, healthier planet, why it's vital for brain health, and also why it's so critical for our nation's public health. This symposium this year is made possible by the following sponsors. Our title sponsor for this year is the National Marine Sanctuary Foundation. Our gold sponsors are Alaska Seafood Marketing Institute, Glacier Fish Company, and Starkist. And also, our silver sponsors are the Chilean Salmon Marketing Council, the Global Organization for EPA DHA, and also Pacific Seafood Processors Association. I'd like to recognize all those that are part of the S&P stakeholder with us that are here today. So when I announce you, please raise your hand to show that you're here with us in this lovely building today. I'd like to recognize our S&P board members, and I see several few of you here today. Thank you for being here. Also, our S&P Scientific Advisory Council. Thank you for being here. Yay! And our NEC Council Task Force, our chair, Bill Hefner, is here. Thank you so much. Our Seafood for Health Action Coalition members, several of you are here as well. So we have lots of partners that are joining us here in this conference. And so for those of you that are social media savvy, our hashtag will be seafood4health as you're posting photos and quotes from this presentation, and also a hashtag SOSS2023 on your social media channels. So without further ado, let me introduce Dr. Tom Brenna, the preeminent expert on fatty acid and seafood nutrition. He's a chair of our Scientific Nutrition Advisory Council. He's professor of pediatrics, chemistry, and nutrition at the Dell Medical School at UT Austin. And he served on numerous committees, such as the USDA 2015 Dietary Guidelines Advisory Committee, international policy groups. And today, Tom will be speaking on why prioritizing nutrition for the brain will affirm the national seafood policy and food policy. So, Tom, take it away.
Well, thanks very much. Is this thing on? Excellent. Okay. Well, welcome everyone, and welcome from there you are, and welcome to those of you joining us by the web. We're gathered in a lovely building here that looks like it's about 100 years old. I feel like I've stepped into the set of The Sting from long ago, and we're going to have a lovely seafood lunch with black cod and salmon. So next time come and join us right here in DC. So I wanted to tell you a little bit today about some of the policy things that we've looked at over the years, specializing a little bit in the dietary guidelines process and findings. But first, I'll say a few words about a couple of randomized trials that came to light in 2022, so quite recently, which actually showed long-term improvement in neurocognitive function. One of them was a study from Australia, which was a follow-up of a study, and it was published in the New England Journal of Medicine, and it showed that omega-3 DHA that's provided to term infants in the period that they would otherwise have been in utero caused a 3.5 IQ point advantage at 5 years of age with no intervention in between. This is sort of an extraordinary kind of result. And a second one that I was involved with, which took place in Africa, published in the American Journal of Clinical Nutrition. I addressed this one last year, which used therapeutic foods that included omega-3s, particularly DHA, and showed that toddlers actually around the age of 1 to 2 rehabilitated quickly, and also 6 months after finishing rehabilitation scored better on tests and had a number of, I would say, at least 3 IQ points, maybe 7 IQ point advantage. It's still at that young age. So we're beginning to see studies that show long-term improvement in neurocognitive function as a result of feeding kids the right way. And as I said, these are notable studies because randomized trials we think of as the highest level of evidence, and it's not very easy or it takes quite a long time to do long-term studies over periods of years. Both of these studies took, ours took 4 or 5 years, and the New England Journal of Medicine study took over 10 years. And also these sort of studies that assess mental function are also difficult. This is the first study and that I've already referred to, and this is just a marker that you can see in the New England Journal of Medicine, the 3.5 point advantage in IQ from the kids who got the DHA, and then in our study, these kids were malnourished. They were rehabilitated with a therapeutic food that included DHA. And do I have a pointer on this thing? Not really. Okay. In the plot that I have here on the slides, there is an advantage of a few IQ points in neurocognition as a result of the use of this improved therapeutic food, and that improvement lasted, or actually was tested 6 months later. So these are, and there's other studies like this, and you'll hear from others in this symposium about this. Quite recently, also in 2022, we and others, and you'll hear from Professor Michael Crawford, who's been teaching us about the primacy of brain health for many, many decades, long before I landed on the scene. And he and I and quite a few others published a sort of a synopsis of our ideas about nutrition and brain health. And traditionally, nutritionists have thought about malnutrition in terms of diseases of adulthood, heart disease, cancer, diabetes, overweight and obesity. And it more or less means calories and protein with a few nutrients thrown in. But we like to point out that if one doesn't take note of the nutrients and special nutrient requirements for the brain, we could have something that we're terming brain famine. So not just malnutrition, general famine, but maybe a body that's okay, but a brain that's not so okay. And that results from a shortage of nutrients required for brain development. Omega-3s is one that has brought a lot of us to this story, but there are many others: iodine, selenium, zinc, iron, that in a package is found in seafood as well as any other food, and better than most. And I like to say that when we think about even social matters, so for instance, we talk a lot in the U.S. these days about equity versus equality, and those two things really are not different things. They're the same thing. But I would suggest to you all that feeding mothers and babies properly, all mothers and babies, is what we should be doing, and that's where equity and equality come together. We talk a lot now, and I like this phrase, food is medicine. It's becoming quite popular nowadays. I've been involved a little bit with the World Economic Forum, who's taken this up, and it's just published, as you can see in the upper right-hand corner of the slide, a document just published this year, this month, I guess, which is on nutrition, and it uses this notion of food as medicine, and it resonates, and that's a great thing when messages resonate. But many of us have pointed out for many years, I'm certainly not the first one, that pregnancy, lactation, infancy, and childhood are not diseases in need of treatments or cures. They're in need of specialized nutritional support, as it turns out. It's the kind of support that traditional diets provided, as a matter of fact. And we ought to think more about, let's say, food for health as a general principle, rather than as just a cure for probably diets that are maybe making us sick. We ought to think about the baseline as being food for good health, and that anything different from that is suboptimal, let's say. What foods? Well, seafood is the one we're focusing on today, but we also have quite a bit of evidence that the nutrients in seafood are important. Examples would be omega-3s, and as far as we can tell, the data has been coming in for 20 years showing that omega-3s are good for folks that are experiencing major depressive disorders. There's evidence in the clinical literature and clinical practice that omega-3s are important, particularly EPA, and that's still an ongoing story that we're still trying to work out the details on how it works in the brain, but the data just keeps coming that it's very positive for depression. So I'll just keep going. I note that this year's Dietary Guidelines Advisory Committee is going to take up neurocognition. Now, just as a quick introduction, the Dietary Guidelines Advisory Committee meets and is assembled every 5 years. So starting in 1980, but every 5 years since then. And it's assembled in advance of the Dietary Guidelines for Americans, which is the recommendations and the policy of the federal government for food. And I served on the committee from 2015, so 10 years ago. And in that group, we discussed for the first time the concept and the scientific question, two scientific questions. What is the relationship between dietary patterns? We used to just call that diet, but dietary patterns, what you eat sort of all day, not just individual foods, but how you put together a meal. So what is the relationship between dietary patterns consumed and risk of cognitive decline, dementia, and Alzheimer's disease? And what is the relationship between dietary patterns consumed and risk of depression? And I think this was the first time that we looked at these neurocognitive outcomes in the dietary patterns context. So those are the two questions that we addressed 10 years ago, and that will be updated this year. And 10 years ago, I showed this slide, and so I've sort of pulled it out again just as a bit of maybe nostalgia. But it's an extraordinary documentation that depression is a major problem in the United States, and I've highlighted that approximately 80% of persons with depression reported some level of functional impairment. So this isn't just feeling blue, as they say, and feeling sad today. It's actually a functional issue. And a quarter of those reported serious difficulties in work and home life, and in this and above that highlighted part, 20% of 20 million Americans were depressed, according to national surveys. The magnitude of age-related cognitive decline, this is quite a new bit of statistics, and it shows that, that we're spending something like 350 billion on cognitive decline as the population ages, and then you can see one of these plots here, which is showing numbers globally of in the many trillions. And so clearly this is a big deal, and so if we can find a way to fix it or to mitigate this the advance of this condition, all the better. Now, I won't get into too much detail, but I did put this slide in because this is a general framework that the Dietary Guidelines uses to assess the evidence, or to collect the evidence for any particular question, and it includes things like target populations and potential confounders and so forth. And 10 years ago, we found 19 articles that established to some degree that that dietary patterns emphasizing seafood, vegetables, fruits, and nuts were generally associated with reduced risk, and then other diets were associated with increased risk. But seafood came out on top, and I think if we really went into the foods, the specific foods, we would have found seafood as being a key to the whole thing. We really didn't have time to do that, as it turns out. These are rather busy times. Here is the results from back then on dietary patterns and cognitive impairment, dementia, and Alzheimer's disease. 30 articles were found, and I've highlighted that most of 18 of the 28 articles found an association between dietary patterns and age-related cognitive impairment, dementia, and/or Alzheimer's disease. There were no studies that found that certain dietary patterns let's say sort of seafood kind of diets were negative. They would have been sort of neutral. So there's sort of 28 that showed rather positive effects. And so you remember well, let's see, this might be a generational thing, but some of us remember what Mom and Grandmom always used to say, which is eat fish, and that fish is brain food. And that turns out to be right, experimentally. At least we think. Now, we said that evidence was limited, but there were a number of people on the committee who thought it was actually stronger than limited, and that it was really actionable. And so, with any luck, they'll identify more studies since in the last 10 years and advance that conclusion. So I'm really at the end now, and so I will end. So I started with the 2015 Dietary Guidelines Committee, and I jumped to the 2025, and now I'll just say that the current Dietary Guidelines for Americans, which was based on the 2020 committee's recommendations, really emphasize seafood in a big way. And the Seafood Nutrition Partnership had a chance to put in its 2 cents on this, and I think they went at least as far as we wanted them to go, and probably even further, pointing out that seafood consumption during pregnancy is related, or they say maybe, but that's just being cautious. We think better cognition development and language and communication development in children. Moms that are lactating should continue to consume seafood at the same recommended amounts, and again, also that women should consume fish, which are sources of the long-chain polyunsaturates. And that bowl there that I have in the lower corner there was my lunch on Saturday, which has what I would say is right on of 8 to 12 ounces of a variety of seafood. And boy, was that good. I'm looking forward to getting back to Texas and having another one. So thanks very much for your attention.
Thank you so much, Dr. Brenna. And next, I'd like to welcome up Dr. Susan Carlson. She is the A.J. Rice Professor of Nutrition and University Distinguished Professor at the University of Kansas Medical Center, and also an S&P SNAC member. Welcome up, Susan.
I'm going to use this mic, and I brought my glasses because I had the cataract surgery, and now I never know what I can see. So So, so I'm going to talk today about seafood supports expectant mom and baby nutrient needs. And Tom, thank you for setting me up so well there. I'm not going to talk as much about the studies on cognition, but you've heard about them. But I want to focus today really on what is in seafood, what nutrients are moms not getting, and how might seafood be addressing those nutrients. So my objectives today are talk about what are the recommendations currently for seafood intake in pregnancy. It's associated with brain development, recommendations for DHA or DHA plus EPA, which is that other omega-3 fatty acid in seafood in pregnancy, and how they are supported by seafood intake, and some of the vitamins and minerals provided by seafood that are low in the diet of pregnant women, and the effect of seafood on addressing those potential vitamin and mineral deficiencies. So I'm not sure what this is looking like on the plane. It doesn't look like it did on my screen, but we'll carry on here. So basically the message I'm trying to give you today is that seafood is a superfood. It's a nutritional superfood for pregnancy and lactation. And it contains good to excellent amounts of nutrients required for optimal development, including brain development. So what is the guidance for the U.S. dietary guidelines for Americans, Tom just mentioned, and the American College of Obstetricians and Gynecologists who talk to pregnant women, presumably about what they should be consuming. The U.S. dietary guideline says women who are pregnant or breastfeeding consume between 8 and 12 ounces per week of a variety of seafood from choices that are lower in mercury. And ACOG says women who are pregnant or planning to be are advised to consume 8 to 12 ounces of seafood per week. So the nutrients in seafood that are most associated with healthy brain development, and this is not meant to apply that all nutrients aren't essential for healthy brain development, but we focus on some of these. Tom's mentioned them already. DHA, iron, iodine, choline, selenium. Very recently, vitamin D has now been shown to be important during neurodevelopment. These are nutrients that maybe have more likely to have marginal status in many people. And so I think that's one of the reasons they get some focus. So what are the recommendations? I don't want you to read this slide. There's just a number of organizations that have said between 200 and 300 milligrams per day of DHA or DHA plus EPA. What we know about women's consumption of DHA in the United States is that it's about 80 milligrams per day, and that's what we found in our latest clinical trial that was conducted after 2016. The data before that says about 54. So we have some idea that the dietary intake's gone up a bit, meaning maybe more women are consuming a little bit of seafood more than they did before, but nowhere near the amounts that we would like to see. So I'm sorry, I'm not really sure what you're seeing here, but so I thought I would compare some of the individual sources of seafood compared to the recommendations for 200 to 300 milligrams per day. And I meant to say on the last slide that one of the things, this 200 to 300 milligrams has not had a lot of scientific evidence behind it. But recently in our latest randomized trial, we found that women who consumed more than 150 milligrams of DHA per day and were assigned to get 200 milligrams during pregnancy had a very low rate of early preterm birth. Those are those births before 34 weeks. Whereas women who were consuming less than 150 milligrams actually needed a very high dose of what we gave them was 1,000 milligrams to have that same low rate of early preterm birth. So looking at the individual kinds of sources of seafood that might be consumed, I put a number of them here, and you can see maybe salmon farm down at the bottom. I calculated the amount of DHA plus EPA in 8 ounces, if women had 8 ounces, and then divided that by 7. So this would be the milligrams per day you might be able to get. And you can see that you have to maybe by a combination of shrimp and salmon or some combination of that, you could get to that 250 milligrams per day if you had 8 ounces of seafood per week. Okay, so in addition to DHA, which some of you who know me know that I've spent my whole life talking about DHA, and so it's really a pleasure to be able to talk about other things that are in seafood today. It's really an excellent source of vitamins and minerals, including those that are most important for optimal infant brain development. And those are, I've highlighted again those in red. But I'm going to say something about some of the other ones as well. So many of those nutrients are low in the diet of pregnant women, and intake is low even with supplements. So if you look at the first column, these are data from our recent ADORE trial that was published a couple of months ago. And those of you who are nutritionists know that the EAR, or estimated average requirement, means 50% of women are getting, basically they're getting 50, if you have an ERA, the ERA is meaning 50% of people are getting the 97 to 98% that would normally be the requirement, that would be within the recommended dietary allowance. So we use this in populations to talk about the likelihood in that population that there's a deficiency. And as you can see in the first column, from diet, iodine and choline, which are two of those nutrients that we're talking about are so important for brain development, 55% of women in our trial were below the EAR for iodine, and 84% were below the EAR for choline. And sadly, as you can see in the second column, even with supplements, this did not improve because we're not really putting iodine and choline to any extent in prenatal vitamins. And I'll go down to the blue ones, the potassium, magnesium, and calcium. Again, these are 3 minerals that are not so much associated with brain development as with preeclampsia, hypertensive disorders of pregnancy. And you can see that we have a little bit of a crisis there too, because between 28 and 52% of women in our study were getting less than the EAR for these nutrients. And again, because they're not really supplemented to very large degree, they're still getting that even with supplements. So I thought what I would do is see if a woman consumed 8 ounces of salmon per week, could this address any of these nutrients that moms need to support her health and her baby's health? And so I've put in the first column the EAR, or the adequate intake. For some nutrients like choline, we don't have an EAR because we don't have an RDA. So the choline, for choline, we have an AI. And I've put those numbers in the first column. And then in the second column, again, I calculated how much would be addressed by eating 8 ounces of farm salmon per week. So if the average daily amount of that nutrient that would be met. And you can see for iodine, it would be about 40% of the AR. For choline, 111%. Iodine, even though it's a nutrient of interest in pregnancy, and many women are supplemented, we're not really seeing that it's being addressed much by seafood. Zinc is another one that you can see if you ate 6 oysters. I think we had oysters last night, and I was trying to keep Tom from them. But you can see it's a really good source of zinc. The calcium, magnesium, and potassium, remember, those are nutrients that were low, and they're not being addressed by supplements. And again, they do a pretty good job of providing, just 8 ounces of salmon would do a pretty good job of addressing even those mineral deficiencies. The selenium was one that actually surprised me when I calculated this, because while seafood is a great source of selenium, it's not really a deficiency that we found in our study. We found that women were getting good amounts of selenium, if you go back to the earlier slide. And I highlighted vitamin D in blue because this is one that I have studied myself in our populations, and women of color have very low vitamin D status in this country during pregnancy, and it is of concern. And I do think the recommendations here, like the ER, are really not adequate for what many pregnant women should be getting during pregnancy. So it's actually quite nice to find out that 8 ounces of salmon would provide 300% of what we're saying is the amount women should be getting. So in summary, consuming 8 to 12 ounces of a variety of seafood per week could easily provide the 200 to 250 milligrams per day of DHA plus EPA for women in their childbearing years who are or could become pregnant. And we have a guideline coming out from 24 different investigators that should be hopefully published sometime in the next few months. And we say in that guideline, women who could become pregnant should be consuming 250 milligrams per day of DHA plus EPA, and they should be consuming more once they become pregnant. Choline and iodine dietary intakes are poor, and they're not well provided by prenatal supplements. 8 ounces of seafood per week could meet the AI for choline and half the EAR for iodine. And those of you who, I know Tom didn't mention choline, but there's a lot of information coming out now that there's this wonderful synergy between DHA and choline, particularly regarding mental health and brain health in development. And calcium, potassium, and magnesium intakes are low in many pregnant women. They're associated with hypertension and preeclampsia. 8 ounces of farm salmon alone could provide 12 to 31% of their need. And seafood may be particularly important for meeting vitamin D intake of pregnant women, given the disconnect between intake and vitamin D status that occurs right now. And I thank you.
Thank you, Dr. Carlson. And we'll have a chance to ask questions of Dr. Carlson and Tom Brennan, the speakers, after this. So next up, I'd like to welcome our presenter, Dr. Michael Crawford from London. He's professor of metabolism, digestion, and reproduction, and we had a chance to have him record his presentation earlier. So here's Dr. Michael Crawford.
Good afternoon. I want to discuss the origin of the brain and the implications of understanding that origin for the future of humanity. The brain evolved in the sea 500 million years ago. It's made of fat largely, and it requires specifically marine fat because there was nothing else in the environment to build the brain at the beginning. In those early days, there was no ozone layer, and the planet would have been bathed in very powerful ultraviolet light from the sun. DHA, docosahexaenoic acid, absorbs light in the UV and could well have been the original chromophore. The intense UV would have energized DHA's pi electrons, and that would have led to their escape and electrical impulses, which would have set the stage for the evolution of the nervous system, and then, of course, eventually the central nervous system. Now, of course, it's actually blindingly obvious that the only things that were capable of making these early brains were from the sea. They were marine nutrients. There's an image of the rod outer segments of the photoreceptor showing a very high concentration of docosahexaenoic acid, which interestingly, in the muscle of the codfish, the phospholipids of the codfish comes very close to that high concentration. So effectively, human evolution must have enjoyed the frute del mare, the fruits of the sea, as well as the fruits of the land. And it boils down to this, that we need to save the oceans to save ourselves. That was the theme of World Expo 2012 in Yeosu, Korea. Now, the problem we have is that we have this encephalization based on wild foods of a mixture of land and sea. Now cranial capacity is declining. It's gone in reverse. If you look at the data, the chimpanzee had about 340 cc's of cranial capacity. our genome differs only by about 1.5%. So the wild food from land and sea provided the epigenetic driving force for building larger and larger brains. And to cut a long story short, we come to Herto between 1,600 and 200,000 years ago, where cranial capacity was as much as 1,450 cc. And then more recently, quite close to present day, Cro-Magnon had between 28,000 to 32,000 years ago, had a cranial capacity between 1,500 to 1,700 cc. The average today, I looked it up just quite recently, is recorded as 1,336 cc's. We have lost a very large chunk of our brain, nearly the same size as what we started with as a little chimpanzee. Now, the question is, does it matter? Well, there's the data on IQ from Harvard University, and it has been declining since 1950. There's been a rise in brain disorders. It is astonishing that there's been these 5 governmental organizations, 4 governmental organizations, 1 independent from the Wellcome Trust, all of which put brain disorders right at the top of the list. And in fact, Joe Nurse from the UK commented that the cost of mental ill health in the UK was greater than heart disease and cancer combined. You thought people would have done something about this, but in fact, quite frankly, it's astonishing that nothing has been no response to this extraordinary fact of brain disorders, not only being at the top of the list, but also escalating from 2004 to 2013. So, fish landings. In 1950, we landed 1 million tons. In 2019, it was 600,000 tons. That's the population had increased by about a third since then, so that's a per capita reduction of about 40%. Now, that is just the image of the brain which has been conserved throughout evolution. And this is the motor cortex, the earthanolamine, the inner cell membrane phosphoglyceride. And you see how dominant DHA is. Ephraim Ravine at the Weizmann Institute in Israel did studies comparing rat mothers fed with marine fats or deficient of all the omega-3s. And the yellow dots are the migrating neurons, and you can see the migration has been not completely, but it's been pretty well retarded in the case of the deficiency. There is now a ton of robust evidence which dates back to the 1970s, showing that inadequate dietary intakes of DHA result in behavioral pathology, reduced visual function, learning and cognitive disabilities. One of the best bits of evidence for this is the ELSPAC study done in the Bristol region in England. This is Joe Hebron and Dean Golding's data. And this is data from the over 14,000 pregnancies in which the diets of the mother were studied during the pregnancy, and the outcome of the children at 8 years of age was studied. And after getting rid of all the complicating factors, they were left with this fact that there's a straight line relationship between the benefit of towards IQ with the amount of fish and seafood eaten by the mother. Now, the answer to this is the shrinking brain is that we have to return to the source of a good balance between land and fish and seafood. But unfortunately, we've now reached a limit of both of the wild caught, and we're dependent on the aquaculture. But aquaculture is now running out of wild fish, so it's using chickens and vegetable oils, and this is not a terribly good idea. So what is required is a bold new initiative. And this has been started in many parts of the world, but here's an example of kelp farming. The farmers are now making more money from the kelp than the inland farmers. And in fact, kelp can be used not only as food and as a source of iodine and DHA, but also used as fertilizer for the land to put the iodine back in, and we're sorting out the iodine deficiencies that were highly prevalent in Indonesia. Now, in Japan, they've taken this matter very seriously, and Takahiro Tanaka has developed a marine ranching system, which is essentially marine agriculture between these two islands. He has developed reefs, artificial reefs, each different reefs, different designs to encourage the growth and development of the marine food web for the different behavioral activities of the 7 different target species that they had developing in this region. These are 6 of them. And essentially what he says is implementing several types of artificially provide habitat suitable for different species of fish and also different life stages of the fish. This is in the deep water. But on another matter that he's been thinking about, and that is that on land, our animals are fed on green pastures. So he now is feeding his fish on green pastures in the sea. He's taken restored marine ground-based stuff that had been destroyed by trawling and other activities. He's restored this by planting Restorum marina or eelgrass. And so effectively he has green pastures for the fish in the same way as we have green pastures for land-based animals. And of course it's created jobs for the diminishing fishing community that was going on, and restoring these jobs and the economies of the fishing villages and so on and so forth in a big way. And that's an example. And there are other examples of where similar activities are taking place to demonstrate the plausibility of developing marine agriculture, which is absolutely essential now because according to foresight analysis, the limits of land-based agriculture are being reached in terms of the basis of arable land. In fact, urbanization is eating into arable land, yet population is exploding. In 2000, it was somewhere in the region of 6 billion. In 2011, it was 7 billion. It's now knocking on 8 billion. And this, as David Attenborough says, just simply can't go on without disaster. So the only food I think that we can really rely on is food from the sea, which is completely unexploited. In fact, it has been devastated by the way we've been using the marine environment. And we have to turn this around and do what Takahiro Tanaka is doing in Japan and start developing marine agriculture to not only provide food for the brain to reverse the decline in mental ill health, to reverse the decline in IQ, and to enhance the abilities and health of children of the future. Thank you for listening, and I think I want to point out that listening is just not enough. Action is needed, and we are responsible for the mental health and well-being of the children about to be born. This is a high responsibility. I thank also for all the many wonderful people with whom I've worked since the early days of the 1970s and before in Africa, where I learned of the supreme importance of the specific nutrition of health of the brain. Thank you.
Thank you, Dr. Marco Crawford. Next, our last speaker on the Human Health panel will be Dr. Ole Mouritsen. He's from the University of Copenhagen, and he is a professor of gastrophysics, and he has a fascinating talk for us today. Thank you.
Thank you very much, and thank you very much for having me here today. I will recommend Michael Crawford's new book. He talks about three crises: the population explosion, mental health, and the climate, and claims, and I tend to believe in him, that it's the mental health crisis that is the biggest. This is where seafood comes in. I don't have to convince this audience that seafood is healthy and nutritious and tasty. Now, I like to, in my talk, to combine the two crises, the mental crisis, eating more seafood, with the green transition, bring them together via taste. So what I'm hoping to do is to convince you that the taste in particular get from seafood, I'm going to talk about the umami taste, that can help the global population to eat more green. So we all know from the media and from high-level reports that our current food systems that are responsible for about 30% of the uses of land, nutrients, changes in climate, 30%, more than 30%, we do not have a sustainable food system coming all the way from production, transport, preparation of food, wasting of food. So we have a tremendous problem, and an attempt to analyze this problem, I'm sure you all know from the so-called Eat Lancet Commission report, that in 2019 came up with a suggestion for a planetary menu that could feed 9.8 billion people in 2050 healthy, nutritious, and sustainable food. You don't have to read all the details here, but there's an example of what this planetary menu should be. It's very different from the menu we have in the Western countries. There's something about fish up here, and of course there's something about fruits and vegetables. And this is what I'm going to address first. We're supposed to eat, and we have known this for a long time, 500 to 600 grams fruits and vegetables every day. Now, when I talk about food, and I was only supposed to say one word, I do not say nutritious, I don't say calories, I don't say sustainable, I say taste. Because there's no food that can be considered sustainable, healthy, or or nutritious before it's actually eating. And this is where taste and flavor comes in. If you look through this report, which is a very important report because most national agencies, they use this as a stepping stone to provide for guidelines. You search for the word taste or flavor, it occurs one time, actually just in a bypassing. So the question I'm going to pose, and this is where seafood can help us, that is, can you eat that much? And I'm prepared to stand up here and say, I think it's difficult. I think most people have difficulty eating 500 to 600 grams a day. I'm going to tell you why this is so, and it has to do with plant biology and human evolution, and then I'll look to the ocean to see how we can change this. So we're told to eat all this stuff. And of course, the reason why plant and plant material is more sustainable is because it's on the bottom of the food web. It basically just performs photosynthesis and the nutrients are built up. So on the bottom of the food web, we find plants, but we also find algae. And Michael just taught us about macroalgae, the seaweed, but also little algae, the microalgae. So when I talk about sustainability in the following, the way I'll go about it is to look as deep down in the food web as possible and see how we can eat more of that. And seaweeds is one of them, and of course also shellfish and also fish that may be higher up. I'd like to point out that it's recently been shown that farm seaweeds and farm bivalves are the two most sustainable marine crops we've got. So that's also the reason why Michael mentioned seaweed. But taste comes first. Then the issue is, what do we mean by taste? I'm not going to tell you what is good and bad. We can discuss this forever because that's a matter of tradition, sociological properties, all sorts of things where we differ, and we have different upbringings. But what I'm going to talk, so this is not what I'm going to talk about what you like, what Tom like, and what Linda like. We will never finish that discussion. I'm going to talk about taste proper. That is something that is physiologically based on the palate, because this is something that is unique for all of us. So taste, we say we have 5 basic tastes, and all taste is a combination, by definition, of these 5 basic tastes. And I want to point out that 2 of them are extremely important for understanding how you can eat more in a more sustainable way. And the one is sweet, and the other is umami, and then bitterness comes in along the way. So this is my most provocative slide. I can tell you when I speak about the green transition and where there are vegans and vegetarians in the audience, they say, you are not supposed to say that, because I say vegetables, they don't want to be eaten. They're not supposed to be eaten. The only thing that is supposed to be eaten, seen from the point of view of the plants, is the ripe fruit, because that's the way of reproducing the species. And if you ask what kind of basic tastes, I'm not talking about taste preferences, basic tastes, something we could measure, there are 2 tastes that are quite often absent. That's not sweetness, because the sugars abound in carbohydrates, which have no taste, and they have no umami, because the amino acids and also the nucleotides, we'll come back to that in a second, they're also bound in big molecules which have no taste. So generally, the green stuff don't have sweet and umami, and because plants can run away, they develop the chemical warfare in terms of bitter compounds that we're supposed not to eat. So this is what we are offered when we say you have the green transition. You eat this 500-600 grams of fruit and vegetables, and I'm not talking about the ripe fruits, which are supposed to be eaten. We'll get them for a while. But we do not get any sweetness, we do not get any umami, sort of the big picture, and on top of that, we get some bitterness. And if we ask what kind of basic taste our species has evolved to crave, because it's been good for our evolution, that is precisely sweetness. Sweetness signals sugars. Sugars are calories, good for evolution, good for running a big brain. And we also search out umami, because we are meat eaters. We've been that for more than 2 million years. Ever so often after we started using fire 1.9 million years ago, the signature of meat, broken down meat, is umami via free amino acids and free nucleotides. So that's the trouble. But once you set that, and you can see it, you can tell yourself, we're going to eat green, it's against our evolutionary path, so what do we do? But once you set that, there's also a solution, because what do? You add what is missing. You add sweetness and add umami, or you can release the inbuilt potential of, for instance, vegetables by fermentation. I'm not going to talk about that, but I'll mostly talk about the first part, and in particular how you can add umami. So that's just a little bit, the only bit of chemistry I've got here, which is quite often a surprise to many who say you should eat, for instance, beans, various kinds of pulse and legumes, because they're rich in proteins. Well, they're not very tasty, because all the good tasting stuff is tied up in big macromolecules. So for instance, you have here the starches, you have proteins, it doesn't come through that very well. You have the fats, none of these have taste. And well, you say fat has taste. Well, it's not the fat itself, it's these various taste molecules and aroma molecules that dissolve in the fat. The nucleic acids also have no taste. We hardly ever talk about them in the context of nutrition. They don't mean much for nutrition, they mean a lot for taste, because the individual constituents of nucleic acids are so-called nucleotides, which you find a lot in muscular tissue, and hence in the tissues of seafood. They're very rich in these nucleotides, and once they get free, they give us umami taste. The little thing you need to know about umami is that it is a basic taste. We know how it's one of the few receptors we really know in so great detail. We know why it's working the way it works. It binds glutamate, which is the salt of one of the most prevalent amino acids. It's bind glutamate, and then there's another binding site which binds free nucleotides, which could come from meat. It could also come from fungus. It could come from a few types of ripe fruit, for instance, tomatoes. The wonderful thing about umami is that when these two different things abound at the same time, there's a synergetic principle. So you just need a little bit to enhance the flavor of the other part. And this comes in as a very important element when we want to add something to the green stuff which is missing. So a bit about the first root here, and soon we'll come to the seafood. We'll we would have to add something that is missing, and this is what you use in the kitchen now. And eventually I'll end up in the kitchen, because what I'm going to tell you, all of us can use at home. So we use different kinds of marinades, stock sauces, and dressings, quite often without any fat. And you can actually do that if you know how to add umami. And there are various sources you can get the umami from, typically of animal origin, algal, that is fungus, and algae, both micro and macroalgae. And the point I want to make, and I'm not addressing the vegans and the vegetarians, because they will never be the majority in the world. We still would have to use animal resources, whether it's land animal or sea animals. And I'll advocate a flexitarian approach where you lose a little bit from the animal kingdom to add the missing umami to the green stuff. And this, of course, where seafood come in. So I'm not going to talk about this. So this is where seafood comes in. We can get a lot of help from the ocean. And no matter where you turn, where you look to fish, shellfish, crustaceans, seaweeds, mollusks, they are all very rich, as you all know, in flavorful compounds. In addition to that, they carry the very important superunsaturated fatty acids, which is the core of this symposium when they'll bring them in. So they'll both bring taste, the taste we need for green stuff, as well as the healthy nutrients. Here just a few things. I've been working recently a lot with roe, fish roe, and earlier with cephalopods, squids, octopus, and cuttlefish. This is just for some of the experts. They're very high in the omega-3, omega-6 ratio, and the prevalence of the fatty acids are the long superunsaturated DHA and EPA. So there's lots of them, and you can see, for instance, in the cephalopods, it's just been mapped out recently, and now with marine roe, they're very high. And the point is that they also are very high in free nucleotides and free amino acids, and it blows up the umami. So you get both of the two things at the same time. You all know how fermented products, which contain a lot of proteins, it could be seafood, but also other high protein sources. I'll mention a few things about the features, salient features of cephalopods and seaweed, and then I'll show you a few examples how one can use it. So the reason why I started becoming interested in cephalopods, that is squid, cuttlefish, and octopus, is that whereas the fish population has been dwindling over recent years, all species of cephalopods throughout the global system have been on the rise for the last 60 years. We don't know why. It's likely to have to do with changes in climate and sea culture, in sea temperature. And you don't have to read through this. It's basically the same story of fish. They have all the goodies there, and they also have a composition basically like lean fish. So they have not a lot of superunsaturated fatty acids, but it's mostly in the form of phospholipids. So it's good portions. And as I mentioned, they are on the rise, so why not eat them? So I wrote a book about this with a chef a few years ago, and I have a copy here which I'm going to give to Linda. And the subtitle is Seafood for Today and for the Future, and it's a lot of recipes how one can work with these organisms. So just to show you how powerful they are. So you all know they're healthy and good for you. Now I'll show you how powerful they are to imprint, to give the umami we're missing for the green stuff. And because of this synergy, I say the little thing that if you have co-binding of glutamate and nucleotides, they make the taste blow up. It's a highly nonlinear effect. We know on the receptor level, this is what the chemists call allosteric action. We worked on the receptor, we know how it works. So there's a formula here which describes this nonlinear behavior, and it blows up, and you may see that you have glutamate for different species. You have squid, different parts of the squid. You have oysters, two different kinds of oyster scallops, compared with chicken, and then some rows below. The point is that the left column there, left-hand column on glutamate, it has various amounts for these different species. What really is important is that you have these nucleotides. And together, if you go to the very right-hand side, you can see that the power of magnification is just tremendous. And this is what you feel on the palate. Taste intensity is about, in these units, about 30. So you can see with something like the European oyster, you're going up to 20,000, 28,000. It's really boosting. And to some of you who, I know you just learned you like oysters, Tom. In fact, I can tell you, part of this project was actually started in an oyster bar in Denmark, because we were discussing which kind of oyster do you like best, the Pacific oyster or the flat European oyster. And there are various opinions about this. So I said, why don't we go back in the lab and measure it? And it actually turns out that the old flat European oysters is much, much higher in glutamate, much higher in this umami synergy. So now a bit about algae. Also, this is a busy slide, but I can't emphasize more than this. This is really where we have to look for future seafood resources. I'd like to remind you that when it comes to organic production on the planet, that is where we get sort of the most organic production. That's from the algae. They're responsible for about 70% of the organic production on the planet, mostly from the small algae, but also the big algae. There are lots of them. They can be grown. They can grow sustainably, best in multi-trophic cultures where you combine seaweeds with fish farms and filter feeders like very kind of bivalves in order to each organism can support themselves. There are 12,000 different species, and think about how many you actually eat of them. So there's something to explore here. And you can tell my approach is I start in the kitchen. I'm interested in food. I work with chefs. So we coined this word phycogastronomy in a number of papers. There's also a book that came out a few years ago. I listed these 3 articles, and I would like to point to the middle one, which may be of interest to you. There's a review paper. This is a different Cornish, a different Cornish. But this occurred in a macroalgae journal. But we sort of looked at the constituents, the different kind of nutrients in seaweeds, and tried to see they actually, you have got everything they need there in order for brain evolution. We cannot prove that this was part of human brain evolution because we can't tell if people ate it, because it leaves no evidence of being eaten. But it was there, and I'm sure the burden of the proof is on the other side, that is that humans did not eat it. Of course they ate it. So some of the questions, and they're nutritious, they're also flavorful. Actually, the word umami was coined by a Japanese chemist in 1909 after analyzing the very fundamental of Japanese cuisine, which is dashi, a particular kind of soup broth that is made from an extract of seaweed together with an extract of fish, or for the vegans, an extract of shiitake mushrooms. And it's a perfect combination of glutamate on one side and high levels of nucleotides on the other side. And that's why dashi, for those of you who know or work with dashi, is kind of the most powerful broth you can imagine. It can make all green stuff taste delicious because of the umami. So, of course, you could ask what sort of seaweeds will you find it in, and it's almost done. It's not all seaweeds that are high in glutamate. It turns out it's mostly those that are grown in the northern part of Japan, and a lot of the other seaweeds we have in our part of the world are not very high. But I'd like to point out one in particular, which we actually analyzed, and it stemmed, this is dulse. I'm sure you all know it. Go and buy dulse from your Whole Food store. It's harvested in large amount in Maine, very high, very good quality. That's very high in umami, and we know it for sure because we measured it. So let me end out in the kitchen with 2 examples. This is 2 dishes that appeared in a large book which is on green cuisine and sustainable eating, which I wrote together with a good friend of mine who's a chef, with whom I've done a number of books. And in this book, there's also a number. It's not published in English yet. I hope it will soon come out. But there are a number of dishes which show that how everyone, by insight from what I've just told you, umami from seafood, so you can get deliciousness and also healthy food stuff to make us eat more green. So this is a vegetable dish with seaweed that simmered in soy sauce on a carrot, and the other one is based, also goes this way. This is the cabbage dish, actually peach cabbage, that sits in a font of blue mussel juice, and the blue mussels, and then there's also some dashi, and there's also some bladderwrack, which is another seaweed that gives some texture. So with that, I'll thank you for your attention, and I'll emphasize Michael's word, look to aquaculture. This is where we need to go. We need to look for other species to eat in large amount, and seaweeds are some of them. Thank you for listening.
Thank you, Dr. Mouritsen. We're going to set up for a panel discussion with the speakers from the Human Health Panel. So, Dr. Mouritsen, we'll have you come back up. We're going to have a panel discussion with Dr. Brenna and also Dr. Carlson. And I have a few prepared questions, but if you have additional questions for the presenters, please, we have some of our S&P team members with our mics around as well. Wonderful. Thank you so much for the presentations. One of the papers that Dr. Brenna had addressed in his talk, short form of that title is Brain Famine, and that paper was produced and developed with Dr. Michael Crawford, as well as Dr. Brenna and a number of other researchers. So in that, one of the slides that Dr. Crawford showed was in analyzing the nutrition and food system for the last 100 years, what was most shocking is that IQ levels are going down across the world, and our brain size is going down as well. And we've talked about this before. It looks like about a 7 to 9 drop in IQ points for our human society. And I think 7 to 9 points in IQ drop, that doesn't seem like that much. But Tom, how do we think about the drop in IQ of 7 to 9 points? It's not that much, is it?
It's a single IQ point. So the IQ scale is standardized to 100, and going let's say 15 or 30 points above or below captures something like 97% of the population. And when you talk about a single IQ point in a knowledge economy, it's a little like talking about a single degree centigrade increase in temperature on the planet. So we have been spending a tremendous amount of effort talking about saving the climate, but because of 1 or 2 degrees. But I think the IQ story is at least as important, and I don't think it's at least as important. It's much more important because we fix people's. That's not working. Okay. So the bottom line in what I was just saying is that a single IQ point is more or less better thought of as like a single degree centigrade in increase in temperature in the planet. We've had lots of discussions about saving the planet and spending lots of money in mitigating climate change and increase in temperature. And a degree, or I should say, a single IQ point, I would say, is actually much more important than a degree centigrade, just because humanity is limited by our ability to think things through. And it's a meta problem. Thinking is a meta problem because the solution to all other problems depends on the solution to that problem. Let's get thinking right, and then we'll be able to solve everything else. So it's a big deal. 7 points is an astronomical number.
So
in my
we
opinion.
understand with the planet increasing in temperature by 1 to 2 degrees, we've been feeling the impacts of climate change by just a few degrees. Dr. Mouritsen, you had a few comments?
I just want to quote from Michael's book, which I again highly recommend, and that is he make an extrapolation of the IQ to 2080 and finds that way we touch borderline mental retardedness, or what we call retardation, and also quoting someone says, now we may end up being a nation of morons. And one thing, it's bad with having an average that low, but it's worse if it's the politicians that have such low IQs. But it also raises issues with respect to democracy and justness. One can imagine there might be a fight for DHA, just like there's a fight for certain minerals to run industries. And so this is very grim predictions. And so we can all sort of have nightmares about what that actually means. Just as Tom says, we wouldn't like people to make decisions based on not high intelligence. That's maybe something that could be added, is that it's not only the size of the brain that matters. I mean, it's the connectivity of the neural networks. And we know there also at DHA is extremely important, so it's not necessarily the brain size. We do not know whether the Cro-Magnon or the Neanderthal, who also had a larger brain, were actually more bright than us, because the connectivity may be different.
Thank you, Dr. Mouritsen. So, Tom, going back to our food system, in that paper, why is there the factors causing our IQ points to go down and also the brain size to go down?
Well, I'll be brief on this. I mean, there's a long-standing idea that if you just focus on the omega-3s, but the minerals are in there too, that we've discussed about seafood. If you focus on the omega-3s, the omega-3s tend to be the things that go rancid in food. So if you want a long shelf life, then what you do is you get rid of the omega-3s out of your food, and so I guess you do better financially. But you also sacrifice the nutrients, and so we need to rejigger things so that we're not scrubbing omega-3s out of the food supply, and that we restore it. At least that's one answer that I would give.
Okay, and also it was about growing body size.
Oh well, and that's a little more macro thing, but it's easy to weigh a body. It's not as easy to weigh an IQ. So if you could stand on a scale and it says IQ instead of pounds, then we would be doing that. But and the assumption has always been that if you grow a body, then you're growing a brain. But I think it's very clear that's not the case.
Could I say something?
Yes.
Maybe I can. I'll say something about the Diamond trial, which we did. We started in 2002. It was in a low SES population, and there's a test called the Peabody Picture Vocabulary Test that you can give to anybody from 4 to 90, right, or 100. But anyway, the mother's average score on the Peabody Picture Vocabulary Test, which is a quick way of assessing IQ, was 84. The control group who didn't get DHA and arachidonic acid had the same score as the mothers. All three groups that received DHA and arachidonic acid in different amounts had a higher score than their mothers on that test, which I think is sort of proof that giving DHA and we think arachidonic acid is important in development too, but at the same time, in that first year of life, and that's the only time we intervened, and we did this test much later. We followed those children out to age 9, and the effects were still present. We were giving different tests as we went along, but I think that's pretty much proof that we're improving. We need DHA for the brain.
It's also very encouraging that it can, in some sense, might reverse the decrements.
Yes, I think it obviously did, because it.
Well, I'll stick with you, Dr. Carlson. So ACOG, the American College of Obstetrics and Gynecologists, reaffirmed in 2017 the recommendations on seafood intake for pregnant women. But why do you think OBs are not more vocal about the need to feed seafood to women during pregnancy?
Well, I'm not sure that they aren't, I'm not sure they're even aware of their own guidelines. I hate to say that, but I hope there are no obstetricians in the audience. You know, I've worked in medical centers for a lot of years, and a lot of this training or this teaching gets left over to other people. I don't know that, you know, my friends who've been through pregnancies say the doctor never even mentioned nutrition once to me of any sort. I do think we have to raise consciousness among obstetricians. I don't think they get a lot of training in nutrition. They don't really feel that competent to advise pregnant women, and that's why they turn it over to their nurses and maybe the dietitian if there's a dietitian that's available in that clinic. And I think that has a message too for who we should maybe be reaching out to get these messages across, because we need to be, I know there are efforts underway within SNP to reach dietitians. I'm not sure we've reached out to nurses enough with this message, but.
Great. And I guess a follow-up question is, at what point in their education can we build that awareness? Is it during medical school, during continuing education? Is there a point where it makes better sense?
I think during residency is probably the time that we can reach them the most. within the first 4 years, they have so many other things they need to be learning. I'll tell you an anecdote. So many years ago, when we first got DHA and arachidonic acid into infant formula, I spent a lot of time going to doctors' offices on behalf of some of the formula companies, talking to them about the importance. And I can tell you that after my talk, very often the pediatrician would draw me into the office and ask me questions for 30, 40 minutes about nutrition, DHA. So, I mean, I think it's one of those situations where in real time, now I need to know this, and that's the time we can best reach people with messages.
That's great. Thank you. And we'll have our panel this afternoon on consumer outreach and education, so that is right on. Dr. Mouritsen, you know, in our consumer surveys on how to encourage consumers to eat more seafood, time and time again, it's taste. You know, I think a lot of the industry may think price is a concern, whether my family likes it, or you know, if it's affordable, same thing as price. But taste is number one for you. What are some things that that you're doing for kids in Denmark to help them understand how to add more seafood to their diets via taste?
First of all, they should actually see whole fish. And many of them haven't seen a whole fish, and they think fish is something in blocks that is with batter. And it's probably very much like here, even though we are a very small nation, a lot of islands in the sea, we don't eat as much fish as we usually did. I, for many years, worked with outreach to children in a large national program, and some of the things we learned during that process was that it has to do with hands-on. I mean, the kids have to see fish, they have to touch fish, they have to play with fish. And I can give you an example of, we had a very wonderful PhD, the woman who worked with fish and children, and she said, well, we're not talking about eating fish first. Let's do art. And there's a classical art in Japanese called gyutako, and I encourage you to look it up. It's a way the fishermen in the old days, when they had to demonstrate, that was before the time of the camera. You can't say, I caught such a big fish. So what do? They make an imprint on a piece of paper, actually with the ink from cuttlefish. And so making a print of a fish makes you touch the fish, look at the fish, And eventually, in some of the better programs we had, we actually ended up in the kitchen. So it's a matter of changing context. So children, and the same thing with the children, don't like to eat vegetables. If you change the context, if you take them to a school garden, they grow vegetables, cook with vegetables, they'll all eat broccoli. So it's a matter of context. The same thing with fish. When about taste, there's of course something with seafood, because if it's not fresh, some associate taste of fish with the smell of fish, so it's not fresh. And that is something, of course, we have to be aware of. And then there are also the bones. And I think our experience is that once the kids sort of see what the bones are and why they're there, they can better tolerate that this is not just a chunk of meat, it actually comes with something else. And even the bones you can fry, and they're crisp and wonderful. So playfulness, and I don't know, maybe there's something that belongs to the afternoon session, but we've developed teaching materials throughout all levels in the Danish school system involving a lot of seafood, and it is a matter of having teaching materials such that the kids can learn about food and the interaction with food via the senses, and that also involves seafood in any subject in school, even in mathematics and language. So it's sort of bringing the senses back. So that's what it's taught. Another thing we also learned is that if you bring in, for instance, people who work with fish, it could be fishmonger or fish retail sellers, they sort of tell the kids about the fish, show them the fish. It just changes the context, and then they all eat fish in the end, I tell you.
Okay. Well, I'm wearing a fish necklace today. So we should all wear fish, draw fish, and eat fish.
Some even eat oysters, Tom. No,
some oysters.
The kids. Yeah.
I have a few more questions, but raise your hand if you have a question. Oh, Bill?
I just have a question for Tom. You mentioned scrubbing of omega-3s. Can you explain how that happens?
So the question is, I mentioned the scrubbing of omega-3s from foods, and I was using that just as a sort of a colloquial description of the idea that one selects out foods that will be low in omega-3s. Examples would be some vegetable oils that are very, very low or have really negligible amounts of omega-3s, and using those in prepared foods, so there's very little omega-3 in there, and so if you select sort of, and it's well known in the edible oil industry that it is the omega-3, the plant omega-3, alpha-linolenic acid is the name, but the plant omega-3 that actually is responsible for rancidity early on in the life of a food. So if you can get rid of that, then you end up with a longer frying life or a longer shelf life. And so it's a matter of just kind of, if that happens with one food, okay, but if everyone knows that and everyone is choosing to get rid of the omega-3s, then you end up with an entire dietary pattern or an entire diet and food supply which has much less omega-3. And these are points that were made by sort of early omega-3 scientists in the 20th century, and I'm just sort of more or less repeating them.
So that's not happening with seafood, though, because I don't know how you strip that out.
So the question is that happening with seafood? And the answer is that if one, well, it depends on what you feed if it's for farmed fish, it depends what you feed them. I don't know that they're purposefully, that the producers are purposefully doing that, but I can tell you, for instance, catfish in the South, that people eat a lot of catfish in the South, but it has very little omega-3 compared to the wild. The wild has 3 or 4 times the amount of DHA, for instance. And so I suspect that's in part a cost issue with regard to the feed, but I also suspect it may have something to do with shelf life.
Andrew Tomlinson has a question.
Thank you. Is this on? Yes. As someone who's boots on the ground workforce development and fisheries, I just want to say I find your work both inspiring and encouraging, and I appreciate science nutritionist, seafood nutritionist. So my question is there any work being done in Europe or the United States or elsewhere in the world with young adults with developmental delays, intellectual disabilities, so 80 IQ or lower, and introducing seafood into their diet and monitoring any increase in their IQ as a result of that?
Great question.
You answer all the questions.
Yeah, I'm not aware of such studies. One of the things, there have been some work done with children that have ADHD, and by one of the guys at University of Cincinnati, and he has shown that you can improve, behavior. One of the things that's causing me to stop and think about this is that one of the things we know about early cognitive development is there is a window for when that can be improved. I think you can improve certain cognitive behaviors after that, but you can't do that without continuing with the diet. So I think the ADHD story would suggest to me that maybe it would be worthwhile to certainly improve the diet of children, but it may not correct their underlying problem.
Yeah, I haven't thought of any studies that are really on point as to what you've asked about, but so
can you talk about Dr. Hibbelin had a study in, I believe, Wisconsin schools on feeding kids omega-3 drinks, and I believe there is less domestic violence at home and better attention at school.
And
is that
those
similar?
are that's in the ballpark, I guess you could say. So in that's a small number of studies, and so there is but the evidence that he developed is that if he gives school-age kids omega-3s, their parents' mental health improves. I'm not making that up. Anybody who's been a parent doesn't have to think twice about why that might be the case. So I really like that one. We should emphasize that.
Okay.
Yeah, I think that developmental disorders, that would be a really good group to look at. But I do think, I do think that. There's plenty of information that seafood improves mood. It's a hard science to measure, but over and over again it comes up as water, seafood, fruits and vegetables. People feel better when they eat this way, and children. I think it's maybe across the board, not just people with developmental disorders. We need to improve the intake of these foods because people feel better.
Well, Dr. Carlson, I want to elaborate on what you just said, that people know that eating healthy with seafood and vegetables and drinking plenty of water is good for how we feel and mental health. I think for those that are watching from the seafood industry, from the food industry, the science is known that eating seafood and vegetables are really great for heart health, and we're discussing brain health more and more now. Can you elaborate on the strength of science that we can say seafood is strong for brain health? I know it's been discussed since 2015, your talk, but tell the audience that strength that we can rely on at this point in time. It's a Susan question. Okay.
Well, I already told you about the diamond study, so obviously I think DHA is important. But I think these things are hard to study because it's hard to do a seafood supplementation study and then measure mood, health. And, this was pointed out by Tom in the beginning about clinical trials. When we do clinical trials, they're expensive. They take a huge number of people to conduct them, skilled people. So it is unfortunate that we're often relying on more epidemiologic type of studies or observational type of studies. But I think there's also plenty of evidence to use to convince people that these are important for brain health. And especially, this is why I wanted to emphasize the nutrients that are in seafood. we end up in our trials giving supplements because we really can't trust women to, it's hard to give them salmon and tell them to eat it. But I'll tell you one thing. We did the Kudos trial in 2006, and the primary aim of that trial was, can you improve cognition of children by giving their mothers DHA during pregnancy? And we didn't find any benefit. Admittedly, it was in the era that all babies got postnatal DHA supplementation, either from their mother's milk or from infant formula. So maybe that's about the window, the timing window of brain development, that they got plenty of it after they were born in the first year of life, so that's why they didn't benefit from pregnancy. Supplementation. Our trial is not different than any of the other trials that have been good randomized trials with DHA supplementation. But if you look at the literature, the studies that have looked at seafood intake during pregnancy show over and over again, and many of the people in this room were party to the 2 papers we published in PLEFA a few years ago, showing that in those studies where women were eating fish, over and over again, it shows improved cognition in the children. So it's caused me to think, okay, maybe just this DHA alone, in the absence of adequate choline, iodine, and all the other brain-building nutrients that we know are low in women's diets, maybe that's why we're not finding the benefit with the supplementation studies. So maybe we need to do the fish supplementation studies.
Martin, Paul,
Just one question, Susan. When you were doing the parent study for the infants, did you measure a dose dependence in the parent or the mother? Like, was it 400 milligrams or 1,000 milligrams? And was that a variable in what you didn't have the outcome you were expecting? It was so low that the background diet that the mother would have had, omega-6 rich, blunted the biouptake at the enzymatic process that didn't let that DHA supplement be absorbed.
I don't think that was the case because we gave them 600 milligrams compared to a placebo. You're talking about the pregnancy trial? We got a dramatic reduction in early preterm birth. That's why we conducted the ADORE trial in 2016 to see, because in the clinical trial arena, if it's not your primary aim, you can't make any claim about it being having worked. You can say, well, it looks interesting, we better do that study. So we did this trial with the primary aim to see if we could reduce birth before 34 weeks based on the Kudos trial. So I know the women were taking it. Whether that's, I guess you could argue about whether the omega-6, omega-3 ratio changed enough or not, but they did absorb it. Their blood levels went up significantly.
and Dr. Agabaga.
So come back to the, thank you, Mike. So come back to the choline question. So now we know that when you take DHA, there are actually specific transporters that take them to the brain and retina, particularly MFDS2 also, I can't remember off my head. And the thought now is that when it is in the lyso-PC form, it's better absorbed than just the ethyl ester form or the free fatty acid form. So with your concept of choline addition, could you elaborate why that would be important, combining choline and DHA?
So this is a little bit a part of the concept that even low fat, lean fish, that Dr. Crawford, he would be answering this right now if he was sitting here, points out that the lipids in those lean fish are primarily phospholipids, and so they are very effective. The question of absorption, I think the data are pretty clear that most fat is absorbed, but when, at least the data that we developed and that has been developed by others in France and elsewhere, you know some of the characters, it shows that the choline assists in directing those fatty acids to the brain as opposed to other places in the body. And so this is another reason for whole fish, and I guess we can assemble a bunch of supplements to maybe in principle to get the same thing, but I think also that the supplementation trials as a general rule are not as positive as the observational trials showing that fish does a better job. So that's why whole food, and it's when you spend your life, I spent a lot of my life, most of my life professionally in nutrition departments, and so you like to talk about food rather than supplements, but that's kind of the way the experiments come out too. That's what we're finding, that it's better to eat a nutrient-rich food than to pop a lot of pills.
I thought you were going to talk about the Caudill trial with the very high levels of choline that they gave.
Yeah. So there was a trial. I mean, there was a trial that was a bit part of, but was driven by Marie Caudill at Cornell, and they gave a certain amount of DHA to all pregnant women, and then they gave a large amount of choline to one group. And what they found was that the circulating DHA was actually substantially higher in the ones that got the choline, which was really very unexpected. That's, to my knowledge, the only known treatment that'll actually raise DHA, other than eating DHA or lowering linoleic acid. So that's part of the same. I think it's part of the same story, though there's some question marks around the underlying stuff.
The other thing was, and they followed those children up, and they have. It looks very much like the DHA story. This early choline supplementation improved cognitive function in those children. And what's really shocking to me is it was massive doses of choline, way above the adequate intake, which really raises the question, we don't know a whole lot about how much choline pregnant women or babies should be getting. And I think we need to be revisiting some of these things, maybe more than macronutrients right now. We need to be thinking about nutrients and what our recommendations are for some of these nutrients and what the evidence is.
I agree.
Well, final question. I'm going to wrap up. Peachy, you have a question?
I'm not a scientist, but I was just wondering, you say the cognition increases with children. Has there been any studies where the effect would be on learning disabilities like dyslexia or anything like that?
I can't answer that because I think it's just on general development of children when they do specific IQ scores, so on, and certain behaviors. I mean, our lab has really focused on using targeted cognitive testing to look at different domains of cognition, but I don't think there have been a lot of studies just focused on something like dyslexia or so on. Again, to do a trial, you have to have enough people to enroll to actually ask the question.
So final question for all of our presenters. Tom, you had said in your the slides that equity and equality come together when you feed moms and babies essential brain nutrition, including seafood. Just a fast round, what are some affordable seafood options that you've seen that would meet the needs for expectant moms?
Oh, well, we have we now have this trend with tinned fish, so canned fish, and
you're talking about hot girls eat tinned fish?
I was going to wait for you to say that. But this would be a TikTok thing, everybody. So those of you at home, just jump onto social media and you'll find this. And there's just a store has opened up in Times Square. So instead of going to get ice cream, you can go get $15 of cans of tinned fish. So these are great ways to preserve the nutrients and do it in an economical way. So I would be looking there. In fact, that's my new thing. I'm going to start
tinned fish.
Tinned fish, yes.
Look for Dr. Tom Brenna on TikTok. He will be showcasing tinned fish. Dr. Carlson, how about you? What are some affordable seafood options for expectant moms?
Okay, well, my latest find is Ecuadorian farmed shrimp at my local Costco at $5.99 a pound, which were the best shrimp I have had in years. So I went back the next week and we had shrimp meals for 6 meals in 2 weeks. And my husband approved, which is really amazing.
So look for sales at your local grocery store.
Yes.
How about Dr. Mouritsen? What are some affordable seafood options?
I think you should eat all of the fish. Because a lot of the fish is thrown away. I mean, in our part of the world, they cut off the roe, they cut off various parts of the fish, so only the fillets are left, and the rest goes to meal to feed livestock, which I think is utterly wrong. So eat the whole fish, and then also we should learn to eat fish that we now hardly see in the store. I mean, in I can tell you in Denmark, the Danish fisheries, they bring in 200 to 300 tons of sprat every year, and Danes never see sprat on the dinner table. They all turn into meal, and they end up as pork, roasted pork, and they can cover 30% of our proteins, and that's animal protein. So I think, I mean, if you really want cheap fish, you start to eat what they call scrap fish, and tinned fish is, of course, a convenient way of getting it. I'm sure a lot of Danes, they get their omega-3 from tinned mackerel. By way in mackerel sauce, it's a perfect umami synergy, and also different kind of raw product in cans, and then some certain kinds of tuna. But my advice would be you should eat the whole fish, and then proportionally it's cheaper.
Well, thank you so much, everyone, for being on this panel and this human health panel this morning. We're now going to break for lunch in the next room, and our nutrition communications manager, Jessica Miller, is there now showcasing what delicious seafood we're going to have to the YouTube audience while all of us enjoy the seafood in the next room live. So come back in about 45 minutes. Thank you.
I can take that back to them if you'd like.
Was that on one of the slides? Because it's a taste attribute.
Hi everyone, Jessica Miller here, Nutrition Communications Manager for Seafood Nutrition Partnership. That was an awesome morning session, and we're excited what the afternoon is going to bring. We are ready for lunch now, so if you're watching virtually, take some time, go outside, take a stretch break, and make sure to get a seafood lunch. If you're here joining us in Washington, D.C., we want to talk quickly about what we're serving today. So we have this amazing Caesar salad bar. We want to give a special shout out to Alaska Seafood for donating the delicious salmon. And also we did confirm that there is anchovy paste in the Caesar dressing. So that's awesome. You all will get your omega-3s there. So we're excited about this. You can kind of dress your own salad here. And now we're going to move over to the second option. We have a taco bar. It is not Tuesday, but we're getting wild here on a Thursday and having Taco Thursday, where you can have some delicious cod, thanks to Alaska Seafood, in your taco. You can also dress it with all of these wonderful toppings here. So it's Taco Thursday. And now we're going to move along to a Filet-O-Fish bar. You can zoom in here. Look how cute these Filet-O-Fish are. That looks so good. And yes, they have some breading, but that's okay, guys. That's okay. The dietitian says so. We also have some amazing desserts down here on the end. We have little individual fruit salads that you can enjoy, and then also some cheesecake lollipops and some mini fruit tarts. So you guys will have to make your way, if you're joining us in DC today, over to the lunch area. We're going to get started. We're going to have our seafood twice a week. We're starting right now.